Hi, and welcome to the handover session of the Data Type Registry developed in the Faircore for EOS project. In this video, I will present the basic functionalities of the DTR, and we will work together through some examples on how to actually use the DTR. To begin, the DTR is based on the Cordwell software developed by CNRI. As the developers of the handle software, an inherent connection to the handle system is included out of the box, which makes it easy to equip every type with a persistent identifier. This makes it easier to achieve fairness in the DTR. As a first entry point when visiting the DTR website, it makes sense to take a look at the documentation over here. Here you can find information about usage, examples, and description of the available kinds of data types. Also, other basic functionalities include listing available types, filtering them, and searching, for example, for test. Yeah, always a good search query. And well, on a technical level, types registered in the DTR are simply JSON objects. We provide a set of schemas that define the set of possible types that can be created. These schemas include a basic description of measurement units, simple and complex schema elements, as well as taxonomy nodes, which can be used on their own or as a facet to organize and cluster other types. Let us now take a concrete look at the different kinds of data types that can be created. The most interactive and easiest way to grasp the concepts is given when actually registering a type. Though for creation, a user must be authenticated in this instance. There are multiple ways to authenticate with our service. One is to request access via the support@pitconsortium.net mail address. So just send a ticket and an account will be set up for you. Also, we are currently in the process of integrating different external authentication and authorization providers in the DTR. Currently, we set up the identity management of the academic cloud, a rather local service for German universities, but more AI providers, including the EOSC AI, will be added in near futures. For starters, we're going to log in with basic credentials. I'm already logged in, but let's repeat that. Here under external, you can log in via the academic cloud, and in the future, we'll be able to with the EOSC AI. Now we're going straight with username, password. There we go. Now I'm logged in. Okay, now we continue taking a look at the currently available kinds of types that can be created. Sorry. We're going to start with taxonomy nodes, since they can be used as properties in all other types. So it makes sense to start there from the bottom. So we click on create and select the taxonomy node. There we go. Now all kinds of types begin with the same set of common properties that are shared between them, starting with the name and a description. The name is a mandatory field, so each type needs to have a name. The identifier field for the handle value will be automatically generated, so you don't have to worry about that at all. The next property is for versioning types. Here users can reference other types of the same kind as a previous or next version. So here we can see you can only enter taxonomy nodes. So this creates basically a linked list of types where one can reference the latest version of a type. A list of contributors may be added with a name and corresponding ORCID. The expected use field should describe how the type is actually used in practice. And a list of aliases can be added to help better identify a type while searching. And with a reference field, any external source can be cited here. Now, the most important part of the taxonomy node is a list of taxonomy nodes that can be set as the parent elements of the current type. This allows for the creation of an arbitrarily complex net of taxonomy nodes, and in turn, other types as well. Next, we move to measurement units. So that create a measurement unit. Now we see they share the same set of metadata information as taxonomy nodes. So we're gonna skip over that. But as you can see, we can add a list of taxonomy nodes to add additional custom faceting to the type. This is Now the case for all other types except taxonomy nodes. And well, the set of specific properties regarding measurement units is actually pretty self-explanatory. You have a name, a unit symbol, a quantity, dimension symbol, and so on. So I'm not going to delve deeper into that. Way more interesting, we will take a look on how to register metadata schema elements and entire schemas in the DTR. Now, as the basic property, we consider so-called basic info types as single, simple schema elements. We're going to create a basic info type. As you can see, yeah, again, the basic metadata fields are the same. But in addition, each basic info type can have measurement units associated with it. Now, this conveys additional information about the schema element in a very simple way and references the PID of the measurement unit again. So, but the most interesting part when it comes to describing the actual properties and restrictions that need to apply, that some object can be considered to be of that certain type. For that, we differentiate between the atomic data types of string, number, Boolean, and enumerations of those. Now we can add certain restrictions that apply to the selected data type. Here we can see we can select a number or a Boolean and so on. For now, for example, we're going to use a string. Now, after selecting a string, we can add certain restrictions to the string that need to be applied to be a valid object of that type. For example, we have string-specific restrictions like the minimum length, the maximum length, and the regular expression. We can have, for example, a min length of 0 and a maximum length of 10. So any string that is between 0 and 10 characters long would be a valid object of this type. Now, a bit more complex, we could choose, for example, 2 different regular expressions and set as relation between those properties the XOR operator. Now, this would result in a type that, pardon me, I don't have any smart regular expressions on hand, but we could imagine, for example, 2 different date formats here. Now, in this case, an object would be a valid object of this type if it would be of one or the other date format. So we can cover multiple fields with that. But for our simple example, let's go with a min and max length string object. All right. Yeah, it needs a name. That's a mandatory field. We just call it test type. It's a very creative name. And that's it. Perfect. Now, oh yeah, sorry, one thing I missed. We can click this object together in the UI, or we can just create it in the JSON view, which is maybe for experienced users a bit easier to work with because it's a lot more compact. And if you already exactly know what you want, you can be way quicker with this. All right. Now, after saving the type, we can see that it's now been assigned a persistent identifier. This is great. And we can see the URL also is this contains this identifier. So we have the URL of the DTR, and the path objects, and then just the PID, and that's it. We can see that the object's path here has this pound sign in front of it. Now, if we remove this pound sign, we get the JSON view, which is in most cases what you actually want to work with if you are using the types in another application. But for human readability, it is of course better to have the UI view. Now, this brings me to another point about resolving the PID of a type. So now we're going to do a little excursion to the to handle.net. I'm just going to copy the ID and we're going over to handle.net. Now here we're going to resolve the PID of our newly created type. We are not going to redirect to URLs. This is very important. And this is basically the handle record for a created type. As we can see, the type pretty much only has this weird lock parameter. This basically just stores multiple URLs for automatic redirecting. Now we can see that one of the URLs, so 2 URLs are registered. We can see that one of the URLs is the basically the JSON view without the pound sign, and the other one is the UI view with the pound sign here. Great. And with a weight of 1 here, the UI view is basically the default view. So when we are now resolving this handle, we're going to get redirected to the UI view, which because it is the weight 1 and is thus the default view. But yeah, we may want to resolve the handle and directly get the JSON record without any extra steps here. And this is possible. It's a bit tricky and not well documented, so I thought it would be important to add this here. We're going to have adjust the PID here, and yeah, Chromium already knows what I want to do. The logAd view JSON. So this suffix here tells the location parameter and the handle record which view we want to go to. So if you want to go to the JSON view, the handle automatically redirects to the JSON view of the type. Great. Now let us end this excursion here, but I thought it would be important to know and return to the type registry. So when we look at the JSON view of the type, we see that it has a very specific and custom layout. Now, to properly use it outside of the DTR as a schema element, actually, it needs to be converted somehow into some standardized format. And for this, we use this so-called type API. You can find a link in the documentation for this. That's, there we go, type API. Copy the PID again. And yeah, well, this service offers additional functionalities to work with types outside the DTR in an effective fashion. Available endpoints include a nuanced search system, filtering system, retrieving types that belong to a subtree of a taxonomy node, to actually use the faceting system of the taxonomy nodes, and also means to actually validate content according to created types. So let us now create a JSON schema for the type we just created. I copied it, and we have the types schema endpoint here, where we enter the prefix and the suffix. There we go. The refresh flag here is because the types are actually cached in the system, and if we do some changes in the DTR, we want to refresh the schema representation of the type. So there we go. Okay, we have a JSON schema. Object is of type string with a min length 0 and a max length 10. Great, exactly what we wanted. Now we can even go one step further and actually validate content using this service. So we can use the types validate endpoint here. We enter the PID of the type we created, and now as a request body, we enter the content we want to validate. So now we only have valid objects for this type are any string between 0 and 10 characters. So let us first validate test. Is test a valid type? The response body says valid. Great. Now, if we want to validate test as test, which is more than 10 characters, we see, we get an error. It may only be 10 characters long. So this service can validate content against just the PID of the type. So you basically save some extra steps. Of course, you can also have this as a curl command, but you all know how to enter a curl command. I'm not going to bore you with that. All right, where to go next? Yeah, let's return to the type registry for starters. Okay, we're going to continue with a more complex data type. Now we're going to create a so-called info type. In info type is a composite data type, one could call it. Again, we have a shared set of metadata. We all know aliases, taxonomy nodes, and for type-specific properties, we can select if we want the info type to be either an object or an array. Now, this is again in reference to the JSON schema standard of objects and arrays. So we can see an array can have min items and max item set is of one specific type. So an array is, an array of objects of one other type here. And an object has a set of properties, which are in turn basic types or other info types. So for our example, we will create an object that takes two instances of our previously created basic type as properties. So we enter our first property. We call it, you can see I already did this before, and yeah, test1 is always a great name. And here maybe the next fields, the title and description fields, are important because they actually appear as title and description fields in the generated JSON schema. This is useful if you want to use the resulting schema for UI generation, for example, where it's important to have a title and description field that can be automatically used. All right, and for the type, that should be this property basically. We can start typing here, and maybe that's also important for the use with Cordra. As you can see, we don't get our created type suggested when we just start typing test, but we can add the wildcard character, the asterisk here, to basically have an infix search that is not as restricted. So we just clicked on test type, and the PID is entered for us. If you know the PID, you can just copy paste it in there, even easier. All right. Here we could enter a constant value that must be the value of the object to be a valid instance of this type. Also, we can set the cardinality of the property. So the cardinality of 0 to 1 would be basically an optional property, and a cardinality of 1 as a mandatory property, and 0 and 1 to n would be a mandatory and optional array. Now you saw we can also just set the object to be an array, but this offers basically a kind of shortcut if the array you need is not very complex and just a list of values. If you need it to be more granular, you have to create an array type first. All right, and the extract properties field is a more advanced setting and can be ignored in most cases. So we have an optional property of test type. We had a second test2 of test type, which let's set as a mandatory array. Mandatory array is 1 to n. There we go. Okay. Okay, and we can also allow additional properties. So that properties that are not defined in the type itself can be properties of a valid object. So the object can be valid even if there are properties that are not in the schema. And we can apply different sub-schema conditions. So as before with the basic types, you can say that only one or any of the properties must be true here. All right, it looks good so far. We have to give it a name. Test info, again very creative, and save this one. Great. Now we're going to again generate the schema for this, just to see how it looks like. And there we go. Perfect. As you can see, we have a slightly more complex schema now with a required property, test2 here, which is not an array. Yeah, I had to refresh. Sorry about that. I had to set the flag. Now we have test2 as a required array. Great. And test1 as just an object of our previously created basic type of a string between 0 and 10 characters. Great. So let's return to the type registry again. And where to go next? All right, yeah. Here we go. We also added a profile data type, which is on a technical level pretty much equivalent to the info type, but it can only be an object, not an array. So this is used if you want to actually register a full metadata schema. It's easier to just have a separation between types and schemas to have a clear semantic separation between them. Also just, yeah, easier for filtering and searching here. Now, everything we did here was via the user interface. Of course, everything I did in the example is also possible via an API. The corporate software itself offers endpoints for basic CRUD operations. You can see that I linked the documentation here in an iframe, so you can just easily take a look at that. It's all really basic stuff. So I won't go really into depth here because, yeah, it's rather trivial, I think. But in the documentation, I added an entire example for the Cordo API on how to authenticate, retrieve an access token, authenticate with that token to create a type. So if you're interested in that, I can only recommend to you maybe work through this example and yeah, create a type by the API yourself. And oh yeah, on the last note, I also wanted to recommend the so-called DTR playground. The playground is basically an exact copy of the instance we just worked on, but creation of types does not require authentication. Also, types created here do not get an actual handle PID assigned. If you look at what's here, the AA type has no real prefix here associated with it, so it can't be resolved globally. So this instance is really just for experimenting, playing around, and getting familiar with the system. But of course, the usage is very limited without actual identifiers because the types can't be resolved properly, and the persistence of data is not guaranteed. So anything you create here will probably be gone in the future, and you really shouldn't rely on that. All right, but I think that is it for now, and I hope this video helped you. And yeah, good luck. Thank you for your interest in the data type registry, and I hope you enjoy working with it. Goodbye.